Hi, welcome back to the third part of this particular problem set. And we are going to look at how to find the derivative of these two functions. So of this one with respect to x and of this one with respect to x. So let's just get right into it. Now, before we get into the problem, if you have not subscribed to this channel, make sure you subscribe to the channel. There will be lots of more videos coming up on how to find integration of function, how to find integration of functions, and how to manipulate functions and differentiation of functions, how to find minimum and maximum points of functions. So make sure you press the bell button, subscribe to the channel so that you get notification anytime I post a new video in this coming week, right? So let's just get started into this one. Now, what we have in the C part is, so let's focus on this function. We have ln of secant x plus tan x. And we have to find the derivative of this function with respect to x. Now, what do you notice? You notice that what? After the ln function, you have a sum of two functions inside of it. Now, this tells you that what? You have a nested function here, ln of a function of x, right? So what you do is, as usual, you substitute a variable for the inside of this function. So this will be the internal part of the function, and this is the external. So that tells you that what you are going to use chain rule. Now, so we make u secant x plus what? Tan x. Then that would make y to be equal to ln u. Remember again, we are trying to move from y to x, but through u. Instead of going from y to x directly, we're using the other route, from y to u first, then from u to x. So which means dy dx is just dy du times du dx. Now we need to find the derivative of y with respect to u. So this is very easy. Dy du is just derivative of ln u, which is just 1 over u. Don't forget, the very first video explains this, how to find the derivative of basic functions. So go to the playlist, which the link is down in the description. Go and watch all the videos from the beginning to this point. That would help you have a ground understanding of derivatives. Now, what is left is to find du dx, which is, we are looking at this, right? How to find du dx. Now, this is sum of two functions, which means we have to find the derivative of the first function, which is derivative of secant x. We add it to derivative of what? Tan x. Okay, so this is basically find the derivative of secant x, and we know derivative of secant x is secant x tan x. Plus, we then find the derivative of what? Tan x, and which is what? Secant square x. So basically what you have here is what? Secant x bracket tan x plus what? Secant x. So that is the derivative of what? This function, secant x plus tan x. Okay, now that you have this, it is now easy to find dy dx, which is equal to dy du, which is 1 over u, multiplied by what? Du dx, which is this secant x bracket tan x plus secant x. Now, this turns out that what? 1 over u, what is u? U is the same secant x plus tan x. We now multiply it with what? This secant x bracket tan x plus secant x. Now you can see that what? This would cancel out, right? This will cancel out. So what you have left is what? Secant x. And that's the derivative of this function. Okay, so this is the first one. So let's move to the second one. So the second one says that we have y as what? Ln 1 minus x over 1 plus x. So this is the second one. So how do we find the derivative of this with respect to x? I think this is quite easy. Again, you can see you have nested functions. Ln is the external one, and the internal one is here, right, which is u. So substitute u for the internal part of the function. Okay, I think this makes sense. So this now means that what? Our y is going to be ln u again. So using chain rule, dy dx would basically be what? Dy du multiplied by du dx. Now, the y du is very easy to find. So the y du is just the derivative of lane function, which is just 1 over u. Now, what is left for us is to find du dx. Okay, so let's do it here, du dx. Now, notice that what you have to differentiate this function with respect to x, you have what? Division of two functions, which means we are going to use what? Somebody is already saying it, which is quotient rule. Okay, so before we find this, let's rewrite u here again, which is 1 minus x over 1 plus x. So the derivative of this with respect to x is, we leave, so we think about this as division of two functions. So let's call them, so let's use different v and w, right? So what the quotient rule says is, we are going to find the derivative of v, so of the denominator first, v prime. Oh, sorry, that is not the case. So let me write the classical one, and then we just solve the problem based on that. Okay, so the classical one is, let me just use this u as the dummy variable. So this u is not the same thing as this one. This u is actually 1 minus x, and this v is what? 1 plus x. Okay, now what does this say? It says that when we want to take the derivative of such function, the answer is just going to be vu prime minus uv prime over v squared. So we're going to use that in solving this, which means v, which is the denominator, times u prime, then minus u times v prime. See, I'm just writing it out based on the formula over v squared. Sorry. Okay. So now let's quickly find this. 1 plus x. Derivative of 1 minus x with respect to x is just 0 minus 1. So it's just, this is just minus 1. Minus 1 minus x. Derivative of 1 plus x is just going to be 1. Okay. All over 1 plus x squared. Now, what happens here is when we now expand this, so minus 1 times this, then minus 1 times this, I'll have minus 1 minus x, then 1 times this times 1 times this. That would give us, don't forget, we can actually rearrange this. So I usually prefer to bring the single terms to the front, so that I will have this. It will be much easier to see. So bring the 1 to the front again. It will be much easier to see how to expand this. Okay, so minus 1 times 1 becomes minus 1, minus 1 times x is minus x, then minus 1 times 1, we have minus 1 again, then minus 1 times minus x, we have plus x, all over 1 plus x all squared. So what does this give us? Minus 2, minus x plus x is 0, minus 2 over 1 plus x all squared. So we are done with this. Then we go back to the initial problem, which is dy dx, which is actually dy du times du dx. So we got dy du, which is just 1 over u, right? We got it before, which is 1 over u. So we bring this here, 1 over u, times du dx, which is minus 2 over 1 plus x squared. Now, what is u? Remember, u is 1 minus x over 1 plus x. So we can quickly do that. This is 1 over 1 minus x over 1 plus x times minus 2 over 1 plus x all squared. Now we can rewrite this as what? The reciprocal of this is just, so this is 1 over this function, which just means the reciprocal of this function, right? So we can write it as 1 plus x over 1 minus x times minus 2 over 1 plus x squared. So this brings us to what? Remember, 1 plus x can cancel the power, so that would have minus 2 over 1 minus x times 1 plus x. So which can simplify into, if you multiply these things out, you would have what? 1 minus what? X squared. And this solves the problem. If you like, you can rewrite this without negative. You can write this as what? As this, so that you can get rid of the negative, and then we have this as your final answer. So whichever one you write will be correct. So That would be how to differentiate this function, which is ln of 1 minus x over 1 plus x. So just follow through the method again, rewind the video if you have to watch some parts all over again. And if you have any question, you can comment down below and I'll be happy to respond to your questions. So that will be the end of this video. Don't forget to like and subscribe to the channel to help the growth of this channel. And I will see you guys in the next video.